Greetings and welcome to the RC Wall Vacuum channel. Today's video is part 2 of the do-it-yourself anodizing for RC parts using the Caswell plating anodizing kit. So what I'm going to be doing today is I'm going to be anodizing some turnbuckles that machined out a few months ago, and I'm going to be replacing them on here with this OBR powered Rovan 450 XLT Frankentruck. So stick around. So in part 1 that I did pretty much almost a year ago, I went through and unboxed the kit and established what was actually in it. So if you're interested to see what's in the kit, you can go back and check out that video. Today what I'm planning on doing is picking up on that and going through and anodizing the parts. We're going to run through probably step-by-step process of what's involved, and I'll cover some of the stuff that you're going to need to get if you decide to do this. That does not come with the kit right from Caswell plating. And keep in mind, I have nothing to do with Caswell plating. I'm not paid to do this, and I paid for the kit, and they have no idea I'm doing the video. So it will be a pretty neutral, unbiased opinion of how the kit is. So I'm just going over a couple of quick tidbits on anodizing information, and then proceed off to doing the setup and running the process. So you certainly don't need to get this kit to do the process. I got it because I'm kind of a scatterbrained nitwit, so I figured it'd be better to get the kit and start with that as a basis and then build off of that. At least to get something started by someone who actually knows what they're doing. So anyhow, anodizing aluminum, it's a controlled oxidation process, and the oxide that forms is extremely hard, and it gives a good protection in the base metal. But now the oxide that forms is, it melts at 3,762 degrees, and that's relevant if you try welding it. It doesn't work well, so you gotta get the oxide off the weld. And it's also a poor electrical conductor, and that'll be covered here in a couple minutes when it comes to hooking the parts into the sulfuric acid bath. So there's 3 general types of anodizing. I'm going to be doing type 2 today, or that's the plan anyhow. But type 1, it uses a chromic acid, and it's usually for like real thin layers, and if you got tight fitting tolerance parts, it works good for that. It usually ends up well under 20 microns. So type 2, like I said, is going to be today's process, and that's an electrolytic process, and it's done in sulfuric acid bath. It's most widely what you're going to see it being used out there on things. And the layer produced is usually around 25 microns if you do it right. So then the third one is hard anodizing. And it's basically the same process, but you just run it for a lot longer and I believe higher currents, and you just get a lot thicker layer, close to upwards of 100 microns. Of course, there's numerous variants of these processes out there as well, and I know like some countries, like the UK I believe, and maybe Australia, it's tough to get sulfuric acid, and they have other types of materials they can use. So anyhow, this one I'm going to be using sulfuric acid, and just a little note here that when we talk about dimensions on this anodizing, 1 mil is equal to 1,000ths of an inch, and that's also equal to 25.4 microns. So a quick overview of the process involved with getting these things prepped and ready to go through and running the process. Part surface and preparation are real critical. If you want a mirrored finish or you want a matte finish, you want a mirrored finish or matte finish after you anodize. You got to make sure you get those finishes before you actually start anodizing the part. I'm kind of going for a matte finish on this. I'm not that concerned. I'm more looking for durability. So the other critical part with these is to make sure they're fully degreased, and fingerprints, everything has to come off of there. So once you really want to degrease your part first, then do your polishing and surface preparation, then go through and re-grease. You don't want to start off doing surface preparation with grease on it, because you might risk embedding it right into the aluminum. So like I said, you got to go through and get them degreased initially, and then prep the surface, and then we've gone through the official degreasing, and I'll go over that when get ready to set that tank up. And you can do a water break test if you're really anal about things, and probably a good idea to do it, but you just look to make sure when you spray water across there, that sheets across there and does not bead up. That's a good sign that all the oils and stuff is removed. So then, when it comes down to doing the actual process, like I said, there's this first, I guess I could call it a second stage of the degreasing, but that's done in a heated tank. Then it's followed up by this de-smut, and that's also in a heated tank with some chemicals, and that breaks off any oxide that's already formed on there, so it doesn't interfere with the electrolysis process. And then that's followed up by the actual anodizing operation, and that's carried out in a sulfuric acid bath. and you got to run DC current through it, and the part to be anodized has to be at the plus, hence the name anodizing. The plus is obviously an anode in this case. And then after that, after you run that through that process, and then the optional one is you want to put color dye on it, and then that you go into that a heated tank with a dye on that, and then the final step is to seal it up with a very hot, just below boiling point water bath. There's also some chemicals involved with that too. So I'll detail is move through each one of these tanks and give a little more information on what goes in each one of those tanks. So before I go into each individual tank and what you need in those tanks, I'm going to go over some general things you might want to get. Obviously sulfuric acid. I had to go to a couple AutoZones and Napa to get it, and the one AutoZone, they just kind of looked at me like I was a terrorist or something like that. But then again, I did have my finest suicide bomb vest on, so maybe that was the trouble. But you're definitely going to want to have a good face shield, neoprene gloves, a timer, some measuring spoons, also something to measure out water. You want to kind of get like a good apron, cover your front, any kind of acid splashes. And I believe the Deoxidation tank is lye or some variant of lye, also not good. Safety glasses obviously, and also a well ventilated area. I'll have this area open up, all the windows and doors open and fan blowing through here. Certainly if you have a more confined space, you might want to have a respirator on. There is a mist suppressant that goes into the acid tank that's supposed to suppress some of the acid mist coming off there. Then of course there's the big one. Make sure you pour the acid slowly into the water. Don't pour water into acid or it'll steam off and blow up in your face. Probably not a good thing. And then just use some common sense when you work with this stuff. So the next step of course is to prep the parts, so let's head over and do that. So this is what I'm going to be anodizing today. It's some turnbuckle bodies I made a few months ago for the Rovan Frankentruck. And I wanted to put them on, but I didn't want to do it until I got them anodized. Now when it comes to installing the parts into the whole system, especially the electrolytic bath, it's pretty important how you tie the stuff in. To link the bus bar on top of the tank, which I'll go over when we get to that tank later on, I have a copper bus bar up there with some brass bolts put in there, and to link that down to the parts, I'm going to be using some titanium wire. The kit comes with titanium wire, but it's a very small amount, so you definitely got to get more. I wasn't originally planning on... So the thing with these turnbuckles, I'm not really concerned about plating the edges down here, just the surface. So I'm going to be actually taking, and I was going to hang them in the tank vertically like this, but I ran into an issue with clearance in the dye tank, so I got to put them in there horizontally. So being turnbuckles, they're right hand, left hand, so finding a left-hand aluminum bolt or titanium bolt is quite the task, so I ended up having to just get some rod, and the lathe came to the rescue, and it's the left-hand studs. I'll be tying the wire to them. But anyhow, it's what you use to tie the top bus bar to the parts is pretty important. You really got to use either aluminum or titanium. Titanium is the best way to go because it doesn't anodize, where if you stick the aluminum wire on there, it does anodize over time. And then you got to get, and since the resistance goes way up on it, you got to keep scraping and anodizing off. So titanium's the way to go. So all I'm going to be doing is basically tying the wire on here and cranking this nut down on this side, and then over here on the left-hand side, I'll be sticking these in here and just wrapping the wire around it to get down in the groove of the threads. And now I have two electrical contact points on this, so that should help the chemical bath a little bit. So then I'll be taking and I'll be setting these things up as is and going through all 5 stages of process with the same configuration, just changing the height when I get to the ceiling and dye tank. That's all it's got to be, just a couple wires hanging off there, and you want them squeezed down as best as possible. That's why usually I want to pinch this so the titanium where it touches the aluminum is protected from the acid, so there's no anodizing going on in that part of the aluminum, so I should have good conductivity. Over here I still will be touching onto this aluminum to a surface and not pinch, but most electricity should go through this side here. So now the parts are all prepped and ready to go, and they've done the initial degreasing. We'll start off here with the official degreasing, and that is in this this tank here, and it's going to be heated about probably 140, 150 degrees. And the mix on this is 4 gallons of distilled water, and then this packet of material, this chemicals here, I don't really know what it is offhand. Some kind of degreaser. This is supplied with a kit. Obviously the bucket is supplied with a kit. For heating it, I went with one of these immersion heaters. Little stainless immersion heater for like pools. And then I got a thermostatically controlled timer on here too. Or not, actually it's not a timer, it's a thermostatically controlled unit. So once that's heated up, it's going to be immersed, the parts will be immersed in there for 5 minutes before you pull it out, and then I'll hand rinse it with a spray bottle into there. Then once it's rinsed off a lot there, I'll pull over and dump it into another tank of just distilled water to finish rinsing before it goes to the next stage. I'll get the chemicals and the tank prepped and heated up, and we'll start dipping some parts. Our 5 minutes is almost up in the degreasing stage. So now we're at the second stage, and this is the deoxy smut area. And I mentioned before, I believe this is lye is used here. They may have some, Caswell may have some own formula. But this bucket's going to take 4 gallons of distilled water and these 2 containers of the chemical. And it gets heated to 110 degrees. I think it goes in there for 3 minutes before being pulled out. And the same way, rinsed with a bottle and then dipped in some distilled water to clear it out. And these chemicals were supplied with the kit. Just like the last stage, the heater stuff was not. I went with the same thing, another one of those immersion heaters and a thermostatically controlled outlet. So I'll get this tank set up and ready to go, and we'll dip some parts. So now we're heading into the deox stage at 110 degrees. This will be in there for 3 minutes. We're rounding the bend on the 3 minutes on this stage, on the deox stage. So here we are at the electrolytic bath part of it. What's not included with the kit is obviously power supply and cables. The bus bar, you got to supply your own. I'm using copper. You can use aluminum or something like that, titanium. It's got to be like this copper here. Once I got it all machined out, then I went through and clear coated it to protect it from the acid. What is included is these lead plates. The kit comes with 2 of them. I only installed the one for now because I'm working with such a small surface area. I'll probably have to put it in the future when I go to start anodizing some like bigger stuff, like I want to do the crack in body panels. So the plates will serve as the negative side, or the DC return I should call it. That is the cathode. This is obviously going to be the anode bar, and the wires will be, the titanium wires will be just draped around there and dropped down in there. To set the lead plate up, let me take a look at this. So you just got to cut them on the side and roll them up, and then clamp it to the side of the tank. And then obviously you want to take and tie both sides of those little ears together electrically, and then back to the supply. So when it comes to setting up the power supply in this, obviously it's got to be DC. You're best to use some kind of a constant current supply. I'm using a 30 volt to 30 amp constant current supply. And like I mentioned earlier, the aluminum oxide that forms during anodizing is a high electrical resistance. So you got to constantly keep pushing the voltage higher and higher to keep that current. You want the current to be steady going through the part for a consistent layer. So with this supply, I should be able to, using a 20 milliamp current density, it should be able to cover 1,500 square inches, and if I go to 40 milliamp, should be able to cover 750 square inches. So the recommended surface area to current is going to be 20 to 40 milliamps, and depending on how much oxide thickness you want, obviously 40 milliamps is going to give you a thicker oxide. And look at 1 amp for every 50 square minutes, operate at 240 minutes, that should give you a thousandth of an inch layer, which is a mil or 25.4 microns. Well, calculating the surface area you're going to be anodizing can be kind of tedious depending on what your part is. Now in this case, it's a pretty easy part to do. So I'm going to have 4 of these in here, and they're cylinders. They're half-inch. They start as half-inch diameter hex bar and machined down a little bit, but they're still. I'm going with a half-inch. And they're 5 inches long. So to find the surface on the cylinder, you're looking at 2 times pi times the radius times h plus, or the height plus the radius. And I end up with 8.2425 square inches per unit. Now to do you got to take into consideration the bottom and the top of a cylinder, except in my case, not so much, because the fact that the one end is going to be blocked with a titanium wire and a nut for electrical electricity to flow through. And the other end's going to have a hole in it, and so there's only just a little ring that's going to get exposed there. So I'm going to keep that in that value in there, but I could probably take it away. But if I didn't have stuff those things in there, to do the top and the bottom of the cylinder is going to be the surface area of a circle, and it's going to be obviously doubled. So that's pi times r squared, and that gives me 0.3925 for the combined in this case, but I'm going to be a little over just because, like I said, there's going to be some stuff in the way. So for the 4 of them, I'm looking at 34.54 square inches of surface area. And Caswell's got they got several calculators on their website. It's under support way down at the bottom. But their 720 rule online calculator yields a result of I need to be 1.44 amps for 120 minutes to properly anodize this. I'm going to be backing that off a little bit because of some surface area issues, and I think the die takes a little bit better if you cut back on your time a little bit. So I'm not going to be taking a lot off that, but I'll be taking off a little of that. So this is the one part of the process that probably will not need to be heated, depending on what your climate's in or what climate you're in. They call for between 60 and 75 degrees. I'm going to be actually probably over that, and I really don't have a good way of cooling that. So I got some distilled water sitting in my basement cooling, and when I get ready, I'm going to toss that in, and that should be probably around 75. So it ain't too bad, but that could have an effect on it. So as far as what you get with the kit, obviously the bucket and stuff like that you get, and the lead plates. There's this mist suppressant that put a couple teaspoons of that on top. That's supposed to suppress any fumes coming up off there, and that combines with these nylon balls that lay on top. They're also supposed to keep fumes from radiating up out of there. So everything that's included in this kit is this little aerator pump. It's meant to go into the acid bath, and it's just meant to move the chemicals around, so that there's always a constant new fresh chemicals around the part. I think there's probably bubbles and stuff forming out of hydrogen or something like that, but I'm not even sure what actually forms there. It needs a little aerator going up to the outside the tank to pull air in and mix with it. It makes a big difference on the flow or the agitation inside the tank. The hose it comes with is way too short, so luckily RC 5th scale RC gas line works good for that. So just got to make sure you lay it in there sideways. You don't want the thing blowing acid up out of the tank. I tested to make sure on regular water to make sure it wouldn't blow stuff up too bad. But as long as you keep it on the side of the tank, it's got little suction cups on there, and it should stay in there, and it definitely agitates the acid pretty good. Obviously, when you're doing all this stuff, you got to pull everything out of here and flush it out real well, flush the impeller out and everything. So one thing I noticed is between their manual and the videos they have online, that there's some discrepancies. Even in the manual, there's some contradictory information in there. But I'm going through and just following the one chart they got on there, and we'll see how that goes. Get this tank rigged up, and like I said before, it does not include the sulfuric acid for this process. You definitely got to get that. So I'll get everything rigged up here, mixed up, and we'll start electrocuting some parts. So we'll start getting the electrolytic cell set up, and I'll start getting with the water in there first. It's 3 gallons of distilled water. I got the pump down in there. Pump going to make sure it doesn't spray nothing out of there. You need a face full of acid. Yeah, she's working good. So I gotta go out the other room and get the acid. So the acid's installed now. I'm going to put 2 teaspoons of this mist suppressant in here. It's supposed to keep the vapor coming up off of it. I don't have a sense of smell, so I can't even tell if it even works. These mist balls got to go on too, but I'm going to wait till I get the parts in there. So let's get the parts over in there now. Alright, well this setup is got to be up to 10 volts to get 1.4 amps. It's in constant current mode, so it'll change as the anodizing builds on, the later oxide builds on the part, resistance goes up. This should boost the voltage to keep that 1.4 amps, because it's showing constant current. So I'm going to leave that in there for about 2 hours and come back. So I'm about in the halfway point right now, and it's still boiling along pretty good. One thing I did forget to mention earlier is that after the acid bath, it has to be dipped in distilled water and baking soda to neutralize the acid before it goes into the dye. And then obviously that mix has to get rinsed off too. A lot of rinsing involved with this process. So the time's up, and I'm going to take and pull the parts out, and I'm going to transfer them over to a bath of baking soda to neutralize them, and then some distilled water, and off to the dye tank. So this kit came with 4 white plastic, nylon plastic buckets, I think 6 gallon, and 2 stainless 5-gallon buckets. And it was never real clear who did what. It seemed the most sense to not use the metal for the electrolytic cell, so that one kind of answered itself. After that, I based it all on temperature. And the dye and especially the sealant are definitely the warmest two of the batch. The degreaser can go up high, I believe, but I'm going to ignore that for now, and we'll see how that goes. So the kit came with this temperature control, or just candy thermometer right here, and I'm not going to really probably pay too much attention to what this is saying. I will to some extent, but I'm going to be heating the unit, since it's stainless, with this hot plate down here, and that's thermostatically controlled. Dyes were not included. I ended up getting a violet and a red. I'm going to run a violet for this process here and see how that works. The mix is 2 gallons of distilled water to one of these 4-ounce bottles. And then the temperature goes up to 140, and it's got to be in there for 15 minutes. So I'll drop I'm going to have to change the height on the parts because of the shallowness of the only 2 gallons in there. And we'll drop them in and see how that goes. So they're over here in the dye tank now, leaving it in there for 15 minutes. And then we'll go off to the sealant tank. The sealant tank temperature is still down a little bit low. I'm going to put a second immersion heater in there. So the 15 minutes is up now on the dye. And this is where we're going to start seeing whether this is working or not. Then we're going to move over to the sealant. We got 15 minutes in that sealant. So we finally reached the sealant step, and this is the last step in the process. So the sealant, like I said, goes up to 210 degrees Fahrenheit, and you're in there for 15 minutes. And you put in 4 gallons of distilled water, and then they have the anodizing sealant, which I have no idea what it is. Put 4 ounces of that in there, and that is supplied with the kit. What's not supplied with the kit was some sort of heater. So I went with a little more, because I was doing some water tests a while back. My other immersion heaters were not able to take the water above like 140, so I had to go with this one here. This is some kind of titanium heater. It's got its own thermostat in here. The only thing I'm a little concerned about is when it sits in this tank, it's a little bit of this up here is exposed, and I think you really want to have these things mostly submerged, so we'll see how that goes. I'll make sure you've got the fire extinguisher around for that one. So this should be the last step in the process, so we'll drop some parts in here and hope for the best. Well, they're violet, but I don't know how well they set in there. We'll see when it gets out of the sealant. Well, I guess I got an answer as to why Caswell sends extra sealant chemical, because you're going to want to change it every time you change your color. So let that go for 15 minutes, and that'll be the test. So the 15 minutes up, I never got the temperature past 196. So hopefully they want it to be like 210, so hopefully that's close enough. I got some things unplugged here. Alright, this is going to be the moment. Yeah, I guess I can touch that. Ooh, actually that looks pretty damn good. Took pretty well. I gotta get in there and rinse. I think they gotta be wiped off with mineral oil. So I'm gonna let these cool and grab some mineral oil and I'll wipe them down. Looks like it took the color real well though. So I got them unhooked from their tethers and wiped them down with WD-40. And actually it worked out fairly well. I was expecting total failure, and it took the color well. It's a little blotchy in spots, and I'm guessing I didn't have the surface prepped right. And I don't know, maybe the boiling or the sealant wasn't quite warm enough, but more like it's a surface preparation. But all in all, I'm pretty happy with the results. Definitely won't be winning any awards with them, but for the first try at it, I'm pretty happy with it. So this was the first go around with this kit, and I'll be doing more. It's a process though, so if you're looking to get into this, be prepared for it to be a little bit of a task, especially getting set up. I mean, once you get a boost set up, then it's probably fly right through it, but I got everything scattered all over the place, and it was all a new process. I have no running water up here, so I got a Caswell distilled water up here. But all in all, I give the kit a very good rating, and we'll be doing more. And next video, I do these rods, I'm going to be sticking them in the Rovan Frankentruck and going up and giving them a crash test on the track. So you watch for that. In the meantime, thanks for watching. Hopefully this is valuable to you.